So we're going to have ln of 3 squared plus ln of 4 plus ln of y. And that's ln of 9 times 4 times y. And that's ln of what? 36y. Okay, it's good practice to put the parentheses. If you don't, it's not too big of a deal. All right, we're going to solve some exponential equations same way as we did with the other bases. E is just another base. So if I want to solve for x, first I want to get rid of this 4, right? So I'm going to do minus 4, 3e to the negative 2x equal to 6. And now divide by 3. E to the negative 2x is equal to 2. Okay, now what? This is what we were doing yesterday, right? Now I have just this here and just one power on the left side equal to 2. So you know what we're going to do? Take the logarithm of both sides. But now, what is the logarithm that goes with e? ln. So I do ln. Yeah, you just take the logarithm of both sides, just like we were doing in yesterday's section, remember? So now this just gives me negative 2x equal to ln of 2. And now divide by negative 2, divide by negative 2. Yes. Because, so ln and e make each other go away because the base here is an e, right? Yeah.
So when you have a base and a base.
Yeah. Yeah. Okay. And now, so what do I have? X is equal to ln of 2 over negative 2. Okay. And let's plug that in the calculator.
Where would we find ln?
Right next to one.
It's
Oh, thank you.
let's see.
No.
It should work. So it helps. Okay, so we're going to do ln of 2 in parentheses. So ln of 2 in parentheses divided by negative 2 is negative 0.3466. All right, go ahead and start on the next one.
Is that e a base and the 4x is like ln base e of 4?
Yeah, it's e to the 4x. E to the 4x, yeah.
So then how can you get rid of the...
Okay, so let's do this. So let's add 12, and we're going to get 3e to the 4x equal to 27. Now, I'm going to divide by 3, right? So e to the 4x is equal to 9. Is that right? Now, when I have a power on one side equal to a number, so a power equal to a number, I'm going to take the logarithm of both sides. The logarithm of base e is ln. Okay? So now, the base here is e, right? So if you have ln base e of e, that goes away. So we just have 4x left equal to ln of 9. I divide by 4, I divide by 4. And now there are lots of different ways of writing this. I can write this as ln of 9 over 4. Another way to write it is 1 over 4 ln of 9, right? Is that the same? Yeah. Another way to write it is ln of 9 to the power of 1/4. Okay? You see how like you could go back and forth with all of these, right? All four are acceptable. You could also do how do we deal with exponents that are fractions? Those are roots, right? You could also see it written like this. Okay? So all of these are the same. And in decimals, so when I go to plug this into my calculator, instead of doing ln of 9 over 4, you know what I do? Because 1 over 4 is 0.25, I just do 0.25 ln of 9. Okay? So that's 0.5493. Okay, so I was waiting for that question. What if on the test I give you a multiple choice question and I have this last form as the answer, but you got that, right? What if you solved and you got this, but in my answer choices, I have this? Would you be able to recognize that those two are the same? Eventually, you're going to be able to.
Okay, well, like I got like the same answer.
Right, but if it's a non-calculator section, right, you should be able to, all right? How could we have written this in a different way? So let's see the reasoning behind it. So something divided by something, that's the same as negative 1 over 2 ln of 2, right? And so now I could write it as ln of 2 to the negative 1/2, right? How else can I write that? Ln of 1 over 2 to the half. You see that? So like you could like take one and go further and further and further. All right, so let's go to this next one. What am I going to do first? Divide by 2. So ln of 5x is equal to 3. And now if I have a logarithm, I want to turn it into exponents, right? If this is a logarithm, then there must be, what is the answer to a logarithm always? An exponent. If that's an exponent, there must be a base somewhere. What's the base? E is the base. So e to the 3 is equal to 5x. Dividing by 5, e cubed over 5 is equal to x. On a non-calculator section, this is a perfectly acceptable answer. You can also write it as 1/5 e cubed. Those are the same. Now, if we wanted to put it in the calculator, then it's, okay, so e is right here. So e to the power of 3 divided by 5 is that 4.017. Okay. Questions? All right. Where is the best place that this is used? compound interest. So in the beginning of this chapter, we talked about compound interest in the first section, was it, or the second one? Second section. We talked about compound interest, and we talked about, you know, what we do if it's compounded semi-annually or monthly, remember? And we said, okay, this is the number of times that you're being paid interest in the year. So if you're in an account that pays you interest semi-annually, twice a year, in January and then in June, the bank calculates interest and pays you money. And then you find a better account that where the bank pays you every single month, so you're getting a little bit more money. Okay? Now, suppose you find a bank account that doesn't just pay you 12 times a year, not every month, not every week, not every day. It pays you every millisecond of every minute of every day. So the computer is just like calculating interest and paying you like continuously. Okay, what's the word I just used? The last word I used? Continuously. When the bank account is such that you're being paid interest continuously, then there is a different situation and there is a different formula. The formula that used to be 1 plus r over n to the power of nt changes, and now there is a new formula, this one. Okay, it's a equals p e to the rt. This is the Purdy formula, right? It's everybody calls it APERT. I call it Purdy because it's Purdy. So what's the same? Is p the same? P is the same. What else? R is the same R, T is the same T, but now you have E. You only use it when you see the word continuously. Okay? So, here we go. Suppose you deposit $700 into an account paying 3% compounded continuously. What is your balance in 8 years? Okay, so A equals P e to the RT. What's P here? $700. What's R? 0. Okay, what's T? 8. Okay, so let's do it. A equals 700 e to the 0.03 times 8. And that's how you're going to plug it into your calculator. The same exact strokes. So it's going to be 700 e to the power of 0.03 times 8. 889.87. Remember, this is dollars, so it's got to be rounded to the proper place. Okay, how long will it take for the balance in your account to reach at least $1,200? How long will it take? I'm looking for T. Okay, what's going to remain the same? P and R. So, A equals P e to the RT, APERT. What's A? 1,200 equals 700 e to the 0.03 t. This is the first time now that we could solve for that. All right, so I'm going to divide by 700. Okay, now don't put this in your calculator just yet. When you're dividing numbers like this, how many zeros can I cancel from top and bottom? 2. So I get 12 over 7 equals e to the 0.03 t. Now what am I going to do? I have a power equals a number. I take ln. So I have ln of 12 over 7 equals 0.03 t. Now what do I do? What do I divide by? 0.03, 0.03. So T is ln of 12 over 7, 0.0 over 0.03. Okay, speaking of becoming the sophisticated math student, you have to divide this entire thing by 0.03. So make sure that fraction bar goes under the entire thing. So why don't we plug that into the calculator? We're going to get ln of 12 over 7 exit out divided by 0.03. And then when you press enter, make sure that that looks like what you put it in, right? So that's 17.9666. And so I think we can round that to 18 years. Okay. All right, next. How much money would have to be deposited in order to reach a balance of $1,500 after 12 years? Now what am I looking for? P. So A is 1,500 equals 1,200. No, 7.
No, I did.
Ah, that's
under
P.
A.
Sorry. E to the 0.03, 12. Okay, 1,500 is 1,500. P is unknown. Here I have e to the 0.03 times 12. That entire thing is just a number, right? It's 2.7 to the power of something. So what I'm going to do here is divide by that whole thing. So P is 1,500 over e to the 0.03 times 12. So let's see how that works. 1,500 over e, oops, e. $1,046.51. All right. And there you have it. Okay, in the time that remains,